Before I take a deep dive into COVID-19, I wanted to touch on some of the new coronaviruses emerging in livestock. As we've seen, COVID-19 is only one of many coronavirus diseases to jump from bats in the 21st century to cause deadly outbreaks. There was SARS in 2002, MERS in 2012, and then SADS in 2016, a new disease killing up to 90% of young piglets. SADS, swine acute diarrhea syndrome, devastated industrial pig farms in the same region in China where SARS had broken out. SADS was traced to a coronavirus discovered in a bat cave in the vicinity, so one could say coronaviruses can infect pigs right off the bat. The combination of deforestation and intensive pork production, with millions of pigs encroaching on bat habitat, may have facilitated the coronavirus spillover from bats to pigs. Then there's porcine epidemic diarrhea, another presumed bat-to-pig coronavirus. In 2010, a highly virulent strain emerged in China that caused massive outbreaks when it hit the United States and spread coast to coast a few years later, killing millions of pigs, approximately 10% of the entire U.S. herd. Then there's porcine delta coronavirus, the third new pig coronavirus to emerge from China in the last decade, rapidly spreading once it reached U.S. shores in 2014. This pattern of emergence and outbreaks of new coronaviruses in livestock appears to be accelerating, facilitated by intensive confinement practices, resulting in thousands of animals being housed together in a closed environment. The pattern of new human coronavirus outbreaks also appears to be accelerating, but currently none of these emerging pig coronaviruses appears able to infect humans. Nevertheless, continued monitoring of these pig coronaviruses is necessary for not just pig, but public health, because coronaviruses are known for their high rates of mutation, and their recombination, the process by which viruses swap parts of their genetic code to better adapt to their hosts or find new ones. The fact that many livestock coronaviruses cause persistent epidemic infections increases the likelihood that a coronavirus mutant could arise with what's called an extended host range, meaning the potential to invite humanity to the party. To trigger a pandemic, the virus would first have to spread to the lungs. Most coronaviruses in bats and livestock to date have been intestinal infections. The exception is infectious bronchitis virus in chickens, which was actually the first coronavirus ever discovered back in 1931, and was to become the major cause of respiratory infections in the 9 billion chickens raised for meat in the United States every year, but is prevalent in all countries with industrial poultry production, with infection rates often approaching 100%. Currently, the only way IBV has been shown to cause disease in mammals, though, is by being directly injected into the brain. But with so many different coronaviruses circulating among so many different species, it's considered likely not a matter of if, but when the next recombinant coronavirus will emerge and explode into the human population. Already, the spikes of the newly discovered porcine delta coronavirus in pigs that has posed such a serious threat to the pork industry can attach to receptors not only in pig intestines, but also in the respiratory tract of humans. This broad receptor engagement of an emerging global coronavirus may potentiate its diverse cross-species transmissibility. We already know porcine delta coronaviruses can infect both human and chicken cells in a petri dish, and we know it can infect chickens themselves, just like there's a bovine coronavirus in calves that can infect turkeys. These coronaviruses jump around, and once they do, which is even more concerning, like porcine delta coronavirus, once it jumps to chickens, can then spread rapidly from chicken to chicken. In fact, this new paper, published February 2020 in the CDC's Emerging Infectious Diseases Journal, just concluded that given the susceptibility of human cells to infection, porcine delta coronavirus should be investigated for its pandemic health risk to humans. The SARS coronavirus can also infect human cells in a petri dish and infect mice in a laboratory. In fact, a team of researchers concluded in an upcoming December 2022 issue of the Journal of Virology that given the ability of SARS coronavirus to grow efficiently in human cell lines, we should not underestimate the risk that this bat-origin coronavirus may jump from pigs to humans. Bottom line, pigs, not just pangolins, may act as the mixing vessels for the generation of new coronaviruses with pandemic potential. Coronaviruses are increasingly emerging and circulating among livestock populations around the world. The more new coronaviruses we have mixing in more and more animals, the greater the likelihood that strains with pandemic potential may emerge. While global pangolin populations are in drastic decline, we produce and slaughter more than 1 billion pigs a year, about half in China alone, raising the specter that the next pandemic may arise from domestic rather than wild animals, an event that may actually have already happened. The last coronavirus pandemic may have been caused by livestock. Wait, the last coronavirus pandemic? Hear me out. Coronaviruses are the second most common cause of the common cold. So far, we've discovered 4 human cold coronaviruses, so that makes 7 coronaviruses in all that can cause human disease, the 6 listed here plus COVID-19. We suspect we got SARS from civets, MERS from camels, and the COVID-19 virus perhaps from pangolins. Where did we get the 4 common cold coronaviruses? The origin of 2 of the 4 mild coronaviruses remain a mystery, but one, called human coronavirus 229E, has been traced back to camels, and the other, called OC43, to cattle or pigs. Well, if the jump by the common cold from camels to humans foreshadowed the deadly MERS species jump that went on to kill 1 in 3 people, might the coronavirus jump from livestock to humans portend a deadly human outbreak as well? It may already have. So-called molecular clock analyses dating the emergence of human coronavirus OC43 suggest that the bovine coronavirus, now causing so-called shipping fever in cattle, jumped to humans around the year 1890. Cows to humans in 1890. That's interesting timing. There was a pandemic in 1890. While the 1890 pandemic was presumed to be influenza, the timing of the emergence of human coronavirus OC43 has led some to conjecture that it instead may have been a SARS-like or COVID-19-like interspecies transmission of a coronavirus. Maybe it was just a coincidence, though? Well, it's not just the timing. There seemed to be a lot of neurological symptoms during that pandemic, and that's relatively unusual for influenza and more characteristic of a coronavirus. But the most compelling data, to me, is the fact that there was this highly infectious respiratory disease raging in cattle. And in the years leading up to the pandemic, 1870 to 1890, there were massive culling operations to eradicate the disease devastating cattle herds the world over, ample opportunity for lots of respiratory secretion exposure. Now, we may never know what caused the 1890 pandemic, but we can take steps to prevent the next one. And that's a subject I dive deep into in my new book. Yes, I go into how to best protect yourself and your family, your community from COVID-19, but I also address pandemic prevention. The best way to survive a pandemic is not to have one in the first place.